Good morning. My name is Andrzej Majker. I am a head of the Department of Aerospace Engineering at Rzeszów University of Technology. As a part of the Assets Plus project, Rzeszów University of Technology developed a new subject of the EQF7 level entitled Computer Methods in Aerospace Engineering. The subject matter of the course results from the current needs of the industry reported during direct meetings with the industrial partners and from our own observations regarding changes in the specificity of the work of the aerospace engineers. The initial concept was mainly focused on familiarizing students with the basics of systems engineering, which is the interdisciplinary field of engineering and engineering management that focuses on how to design, integrate, and manage complex systems over their life cycles. However, in the course of further reflections and discussions with industrial partners, we concluded that we cannot limit ourselves only to the theoretical field of systems engineering, but we must additionally include issues regarding methods and tools used in the contemporary engineering practice. Therefore, a range of issues was created covering both the issues of systems engineering and methodological extensions in the form of model-based systems engineering, which is a formalized methodology that is used to support the requirements, design, analysis, verification, and validation associated with the development of the complex systems. The whole subject has been supplemented with the analysis of the engineering tools used in the form of the computer-aided engineering tools, which means the use of computer software to simulate performance to improve product design or assist in the resolution of engineering problems for a wide range of industries. All the content discussed during the course is focused on the aerospace industry, which is inherently a dual-use area working for the search of civil solutions as well as those in the defense area. The subject is implemented in the first year of the master's studies in the field of aerospace engineering. As an extension of the offer of the Rzeszów University of Technology, a 2-hour course on similar topics was also developed, addressed to the employees of the aerospace industry of the units using the systems engineering methodology, constituting an introduction to the indicated subject. The main educational goal of the new course is to provide students with the knowledge and skills in the field of modern methods and computer tools supporting the process of the conceptual and preliminary design of complex aviation and space systems. An additional purpose is to show the strong independence between design tools and design processes. One of the course-specific objectives is to explain the role of each tool in each product development phase. The subject matter of the course is based on the use of the systems engineering concept in the process of the designing complex aviation and space system. It also includes characteristics of the models, methods, and tools used. The course begins by explaining to the students what the systems engineering approach is. Then the basic methods, tools, and models used in the process of system modeling and optimization of the complex systems are discussed. System modeling language, SysML, is also discussed, which is a specific language used to formally describe systems. Students analyze examples of using this approach in the various areas of engineering activity. One of the most important elements of the modeling process is mission modeling with the use of the digital mission engineering tools. The course ends with the familiarizing students with the typical computer-aided engineering tools used in the modern engineering practice. As a result of completing the course, students receive extended knowledge necessary to understand the main problems in aerospace engineering and specialist knowledge of the methodology and usage of the CAA approach to engineering design of aerospace system. In addition, they receive knowledge about the methods of modeling system using a mission-based and model-based approach. Students also receive knowledge about the most important tools used for modeling and analyzing complex aerospace systems at the stage of the conceptual and preliminary design. Classes are conducted in the form of lectures, projects, and labs. As a part of the extracurricular activities, students will have the opportunity to acquire certain skills, consisting in the ability to define, verify, and validate a list of design requirements, create, verify, and validate models used in the optimal design process, recognize the advantages and disadvantages of the used models, methods, tools, and solutions, select and applies existing computer tools to design a product and solve optimization task, identify optimization task, select and applies optimization method in design, select and apply existing software tools to engineering analysis, design, and optimization, perform scientific research in aerospace engineering, perform computer simulations, analyze and interpret the result, formulate conclusions, write a report of the problem analysis and obtain solutions, draw a diagram and a complex machine element in accordance with the rules of technical drawing, analyze and stress the weakness of the obtained solutions, analyze the literature and publications in the field of aerospace engineering and design, self-educate with the use of modern teaching tools such as remote lectures, website and database teaching programs, ebooks, and others. Classes are carried out in the form of theoretical lectures as well as projects and labs that have a more practical approach. 30 hours of lectures are focused on the providing students with the structural knowledge about the main problems in the field of design and analysis of complex aerospace systems and the methods and computer tools used to support these processes. The 30-hour labs and projects are aimed at consolidating knowledge and developing the ability to apply it in practice. Some lectures are conducted in a hybrid form. This applies to lectures delivered by the industrial partners who connect with the students remotely. Other classes are realized in the form of the traditional classroom classes. Students receive pre-prepared presentations, which are supplementary material for the subject. Classes in the hybrid form are carried out using the hardware facilities at the Rzeszów University of Technology. It means multimedia rooms or computer labs. Classes and labs are held in the computer labs where students can perform various practical exercises. For the subject, pre-prepared materials were developed in the form of the presentations supplementing the interactive lecture. In addition, students can use generally available literature sources, books, papers, and internet sources. As a part of the practical classes, students learn about the engineering software systems that are currently used in the design process. On January 28, 2022, remote lectures for students led by industrial partners were organized. The lectures were conducted by Leonardo, Saab, and Hensoldt. The main topics of the lectures were the experience of industrial partners regarding model-based systems engineering, system of systems, and the others. Students had the opportunity to hear about the experience of the people who have been implementing and using systems engineering for many years. They could also ask questions and could discuss the main problems. Classes are carried out during the normal process of teaching students in the field of aerospace engineering. The requirements for the subjects are comparable to the requirements for the other subjects in the aerospace specialty. For this reason, there were no significant differences between the course plan and its implementation. The only unforeseeable area was the participation of the industrial partners. And the stage of preparing the course plan, and even during the initiation of the course, it means 6 months earlier, it was not known whether and in what extent industrial partners would participate in the course. Also, no significant barriers to the implementation of the classes with students were noticed. The only issue that need to be taken into account during the course is that the students have no previous knowledge of systems engineering concept and no experience in the subject matter discussed. The number of students participating in the computer methods in aerospace engineering course resulted from the size of the groups in the first year of the master studies. However, it was noticed that there are opportunities to increase the number of participants in other trainings prepared and implemented under the Assets Plus program. The most important element is the optimization, is the information campaign and the dissemination of information among interested groups of potential participants. The information campaign should be well in advance of the beginning of the training, and it should be concluded for whole blocks of training. As a result of the implementation of the first cycle of the computer methods in aerospace engineering training, several final remarks and conclusions summarizing the work on the preparation and conduct of the course were formulated. The subject of computer methods in aerospace engineering was developed as a response to the reported demand from the aerospace industry. The subject was prepared for the students of the second degree studies, it means master studies, in the specialization of aircraft and aircraft engines. Second degree students already have a sufficient level of knowledge to better understand the issues discussed. 32 students of both specializations took part in the first edition of the course. The lectures concerned issues related to the computational methods used in the design of aircraft and aircraft engines. Projects and labs classes focused on the practical use of computer tools to create simple engineering tasks typical for the conceptual design stage. A very important element was to support from the industry, consisting in giving lectures in the field of systems engineering, model-based systems engineering, and system of systems. The syllabus of the subject should be developed and improved to adapt it even better to the current needs of the aerospace industry. The general conclusions is that the systems engineering techniques are not understood unless practiced. Thank you very much for your attention.